Okay, so this is the question, why is I a number that's not on the number line? That's what I want to talk about, because when we think about a number, we think about numbers like just 1, 2, 3. Those are numbers, and they're all on the number line. And then we also think about -1, -2, -3, and of course they're on the number line. 0 is a number, and that's on the number line. And then fractions like 2/3 or -3/10 also found on the number line. And the numbers get weirder and weirder, like the square root of 2, the square root of 3, the square root of 23. These are irrational numbers, and so they're stranger because we can't really write them out easily using a decimal, but they're still on the number line. And of course, even square roots can have negatives, so you can say negative the square root of 2. Numbers like pi and e are not only irrational numbers, but they're called transcendental numbers for special mathematical esoteric reasons, and they're on the number line. So first of all, let's just think about that number line that we were talking about, and let's just verify that 0, 1, 2, 3, 4, -1, -2, -3, -4. It goes on forever. So big numbers, small numbers, negative numbers. You can put numbers like the square root of 2 would go right here, and the square root of 3 would go right there, slipped between 1 and 2. Of course, 2/3 would be right about here, and -3/10 would be right about there. Notice that these all are just points on the number line. That's all they are, mathematically speaking. And they're no more weird in that way than just a number like -1 or 1 or 0. These are all just single points on the number line. And now what's the big deal? Oh, and let's, before I get any further, what about pi? Here's pi. Pi is a little more than 3. E is a little less than 3. And again, they're just points on the number line. So let's ask now, how does I, which you may have heard is a quick way of writing the square root of -1. Why is that such a different sort of animal? Why do we say imaginary numbers are like I are not on the number line? So here's the reason. Let's talk about this a little bit. When we're talking about square roots, like the square root of 2, the square root of 3, let's even use an easier one, a number that everybody knows, which is the square root of 4. The square root of 4 is equal to 2, right? The square root of 4 equals 2, and you may already know that. And let's ask the question, why? Why is the square root of 2 equal to 4? It's because 2 times 2 equals 4. So when we have this mathematical relation that we can take a number and multiply it by itself to get a result, we can equally say that if we start with that result and take the square root of it, it takes us back to the original number. But let's also remember that when we say the square root of 4 equals 2, that's true, but it's not the whole story. The square root of 4 is also equal to -2. And why is that? Because remember what we just said. We said if we can take a number and multiply it by itself to get another number, we can reverse that process with a square root. Well, isn't it true that -2 times -2 equals 4? Sure, because negative times a negative equals a positive. 2 times 2 is 4. That gives us 4. So the square root of 4 is equally -2 as well as +2. So this gives us an interesting situation where two numbers, a square root is actually representative of two numbers. Now, why is that a big deal, and how does that relate to the square root of -1? Let's think about that definition we said, where we said a number times another number equals a result, and that's the definition of the square root of that result equals the starting number. We're going to think about -1. So what would be the square root of -1? The square root of -1 equals some value where if you take a starting value and multiply it by itself, you get back to -1. So let's just ask a little bit about this number line. Notice that all the values are either negative. Oops, that's off. So I'll have to move this up. Okay. All the values are either negative, positive, or 0. So first of all, let's rule out, is it possible that 0 times 0 equals -1? No, because we know that 0 times 0 equals 0. So whatever the square root of -1 is, whatever I is, we can rule out 0. Now let's think if it's a positive number. If I take a positive number and multiply it by itself, positive times positive always equals positive. So that means that if the square root of -1 is a number that's on the number line, it isn't anywhere on the positive side of the number line. And then if this were a negative times a negative, that too would equal a positive, which is not -1. So that means that if the square root of -1 is on the number line, it isn't on the negative side either, and that takes it all the way to infinity. So what we sort of done is proved here that if the square root of -1 is on the number line, it's not 0, it's not negative, and it's not positive. And mathematicians take that as a pretty reliable proof that a number doesn't exist, if you can show it's not negative, 0, or positive. And that may be hopefully convincing for you. So now the question comes out, how can something be a number and not on the number line? In other words, where would I put it? It's a number that's not on the number line, and yet I'd like to place it somewhere that's useful to the number line. So for that, let's draw another number line out real quick. Here's 0, here's 1, here's -1, and you know the rest. And now the question is, where would I place this? I'd like to put this right here in the middle. And now the question is, where would I place this? This number I doesn't belong anywhere on this number line. I mean, I could put it over here, but what does that mean? Or I could put it here. I've chosen a space for it, and the place I'm going to put it is right here. That is going to be I, floating over 0. And why would I do that? The cool thing about being able to do that is that if I take I and put it there, I can put twice the value 2I right there, and 3I, and 4I. And then as long as I'm at it, I might as well take -I, if such a thing exists, which by the way it does, -2I, -3I, -4I, and what have I done? I've created another number line, and two number lines together at right angles is just a set of coordinates. And what I've done is I've created the complex coordinate plane. This includes numbers that are both regular, ordinary, real numbers from our number line, and now a solid definition of a real number is a number that appears on our number line, however strange. So these are the real numbers, and these, let's see if you can still see that. There, these are the imaginary numbers. Real numbers and imaginary numbers together create the complex coordinate plane, and this is a good way to work with imaginary numbers in a way that's mathematical, in a way that makes sense, mathematical sense, using all of our intuitions from other math. In the next video, I'll explain a little more about what the heck this means.